We concentrate on three-dimensional light microscopy and their applications thereof, for example, with spheroids, organoids, and tissue sections.
I can remember the very first time I met the organoids very well because I was attending a conference in Vienna, and then I attended a talk by Marichel Uch, who is the scientist who is actually a leader in the field of organoids. And I was really struck because I thought, okay, this is exactly what we're looking for the future.
Well, I think the role of modern microscopy is actually that we are in a phase of transition where we move from monocultures or simple cultures, cells grown on flat and hard surfaces, to multicellular three-dimensional specimens. And then the step to organoids is not so far.
In our lab, we are working a lot with microscopy, and we characterize how the organoid grows and how they differentiate by using light microscopy, and specifically fluorescence microscopy. We use a particular type of microscope, which is the light sheet microscope.
Well, light sheet microscopy is very fast. First of all, it works well with fluorescence labeling, so that is very important. And it has an excellent resolution laterally and axially. And then, of course, what is very important is that the cells survive it. So whatever we look at, whether it's organoids or spheroids or also small model organisms, they survive very long periods of observation.
My role in the project is the wet lab, so that means I'm sitting in the lab and doing organoid culture for expansion, for quality control reasons, and I do microscopy to obtain or generate numbers and parameters for the clinical application. In my opinion, the biggest challenge in the project is the organoid culture itself. Since we get them from Milan, they are directly patient-derived, and we take them back into culture here in our lab, and then they are very fragile, heterogeneous, and we have to give them somehow parameters and numbers, for example by using microscopy, fluorescence microscopy, to define the culture itself and give numbers for the clinical application.
Mainly we have to find out actually what is a healthy organoid, what is a healthy culture, and what are the main quality parameters which are important for this culture. The biggest challenges are actually given by the great heterogeneity within the culture and due to the different donors we receive. And that gives us then the problem to find quality parameters for a healthy organoid culture, because all of these factors like the donor's age or the donor's health influence the quality parameters we want to establish.
The most biggest challenges that I'm facing right now in this project is that I'm gonna figure it out the best way to co-culture different cell types, for example endothelial cells or mesenchymal cells with human pancreatic organoid, and finding the optimal protocol to culture them and lead them in a direction to differentiate to beta-like cells and produce insulin.
Working in a European consortium has the advantage that you can really bring expertise together that is otherwise not available locally. So a lot of the things that we do would not be possible in Frankfurt, but they are possible on a European scale. And that, of course, I think that is really the whole issue.
Scientists are usually very careful when they're asked about the translation of the research into a cure. I think that we are really getting closer and closer to a cellular therapy of diabetes type 1. The next step of LSFM4LIFE is bringing organoids to clinical trial.